Hello, my name is Ramesh Reddy. I'm Principal Software Engineer with Red Hat. There has been many questions about data virtualization and in microservices architecture. Today I wanted to show a small demo with DV in terms of specifically in terms of services and how DV and microservices can coexist. I'm expecting most of my audience today are already aware of data virtualization, and this demo is more to solicit feedback as of the approach we are trying to take. So, so why DV, right? Typically when you are working in a microservices architecture, the microservices preaches that every application should have its own copy of the data. That means its own version of database. So if you are working with a greenfield application where you are developing a brand new application, no legacy attached, that's perfect. The DV proposition there can be little questionable. But at the same time, in that application, if you are doing data virtualization, let's say, data virtualization or data integration more specifically, in my opinion, that can bring in lots of benefits. At the same time, if you are working on a brownfield application, that means you are converting a already existing application with a legacy roots in it and converting it to a microservices based application. In that case, I believe data virtualization can be a perfect match. I will explain why a little bit on that front. So what is, to begin with, I want to give a little synopsis, little brief introduction to data virtualization. What is data virtualization, right? Data virtualization is a logical layer, or you can think of an abstraction layer on top of your database or databases or any kind of a source for that respect. So in a way, you can think of it as at a most basic sense, you can think of it as a logical view on top of your database sources, a logical unified view across all your data sources, right? So where it's you can even think of it. So actually, in the next slide, so you can actually even think it as a real-time ETL. ETL, you are making a copy. With data virtualization, you have the same facilities, but you are not actually making any copy. You in real time, you are interrogating your data sources and putting together the data given the definition of your view, right? You can integrate data from multiple data sources. In data virtualization supports relational and non-relational sources. You can think it, it's not really a server. You can think it as an application utility. We have various different options of how. That's not what I wanted. Let's see. Here, so in here, you can see in the bottom you have various different data sources. A data virtualization technology can sit in between and provide a way to connect to those data sources and a way to compose a view based on the metadata of the sources. You can compose a view, then it can expose that data, whether it's through JDBC, ODBC, or a REST. So a consuming application on the top, in this case, a microservice, let's say, it will look like you are talking to another database. So again, in data virtualization, we call this connect compose layer as a virtual database, as a naming. So we already went through that. So coming to data virtualization, how it is applicable in MSA. There is one way you can think of in microservices architecture. If the green boxes are microservices and the red, if the blue box is your monolithic database, if each microservice needs its own database, we can create those virtual databases, the ones in the red, in data virtual in Red Hat Java's data virtualization technology, such that each microservice application thinks that it's going to a single database. It's changing its database schema, it's doing whatever it needs to satisfy its application needs. But at the same time, these virtual databases are connected to your centralized single database or multiple databases or multiple data sources per application. So it kind of gives you ability to design your Microsoft application with the flexibility you need. At the same time, it satisfies the need to connect to your centralized databases. So here you can do all the schema evaluations in the virtual database, but at the same time you can maintain your schema, your version of the schema, and how it maps to the centralized database, which is not changing at all, because you don't want to change that. You can't change that because there are already existing applications, existing infrastructure, existing in your enterprise, and you cannot go back and change that easily. If you do need to connect to a local databases, a database specific to your microservice, you can still do that in that virtual database. So you can add another database there, and still data virtualization technology can seamless operate between your centralized database as well as your local database. But for microservices perspective, it's a single database it's operating with, right? That's the value add here. So to recap, so every microservice that gets its own virtual database. The users do not need to learn a new technology, especially if people are using NoSQL data sources, SQL data sources, mix up technology. Here we can wrap all those things into a single virtual database and give you SQL-based access to it. And we have a JPA layer on top of it. You can add JPA layer on top of it and use the JPA model on that. So it provides an incremental approach to your your move to a microservices architecture, rather than let's throw away our monolith and start all fresh. So it's much more less risky. And DV is inherently stateless. That means that you can scale it with your application however you need. So so we are proposing in DV, we are proposing two different ways to support DV in microservice architecture. One is DV in an external container, like what I showed you here. The red virtual database is sitting. If you take OpenShift or Kubernetes container, your virtual database is sitting in a different container. Your microservices application is connected to this container as a database and doing its database specific task, whether it's saving or reading data from that. The second one is DV as a library. That means that we are using an embedded database, DV as more used as a library, as a framework, rather than looking at it as a separate entity altogether. That means that any of the SQL or data integration gluing code exists along with your code, rather than exists outside, right? So in this today, I'm gonna be showcasing DV as a library, as an example, as a demo, using Spring Boot. So let's get into that demo right away. So in this demo, what I'm gonna be showing is, hey, using a DV, using Spring Boot, hey, how can I read data data from a RDBMS like Oracle or Postgres. There is nothing specific about DB here, so that's simple enough. Then I will show you how to read data from a comma separated file, and I will show you how to read data from a REST service. And as I read data from each different ones, I will show how I can integrate data from each of these data sources and to provide a single view of all that data, right? So let's get our hands dirty and start with the demo. So for the demo purposes, I thought, hey, why don't I use a Swagger or open service API based demo where I take a existing generate the code from a Swagger based API and then use DB along with it to showcase a development of a service, right? So if you ever use the Swagger online editor, they have a sample application called Pet Store. You can look the pets by status, and they can, there is a store. You can look at the inventory and the user operations, right? So for the purposes of this example, I broke this one into 3 different pieces. One is actually I only implemented 2 pieces, but the one is the pet itself, right? Hey, whether I can find the pet by status, that's pet database. The relevant details about that pet, I have a Postgres database on my local machine where I have a table called animal, and which has a ID, name, type, status, and I have few rows along in there. So the idea is, generate a scaffolding code and read this animal data and show that one as the database, right? That's simple enough to do it with a Spring Boot based application. But to do that, since it also has store, I've broken this one into 2 different YAML files. So basically what I did is I broken into a pet specific one, and I broken into a inventory specific one. So let's import that file and see what operations there are. So there are find by state. There are 4 different operations. Not much interesting here so far. So I'm gonna do a Spring based application. I'm gonna extract into my testing spot, and I'm gonna go back to my testing pet store, and actually let me delete my old one, and I'm gonna rename this as pet service, and I also want to rename my pom.xml to have the same pet service name, right? The pet service pet service. I want to use Java 1.8, and there is a new release of Spring framework. I use 1.5.3. So right now there is only a few Spring Boot or web, some dependencies for using DV, and for using DV I need few dependencies need to be added. So let's add those, right? So I added Spring Boot's JPA project. I added Spring Boot's JDBC project. I added Postgres database for JDBC driver. If you are doing any kind of RDBMS access, you would need JDBC, and probably you need data JPA. So those are already dependencies if you are going to a database. So for DV, or tiered, we call it in community, I added a Spring Boot starter dependency, and I also added a data REST. I'll talk about this one data rest project a little later on, but this is a library that gives me ability to issue calls based on REST API. So I'm gonna save that, and I'm gonna go back to my Eclipse IDE and import that project into it. So that is in my testing, pet store, pet service. Let's finish up that. And so in order for me to access, so I have the pet API and I have a model. Usually this is a little verbose, so what I'm gonna do is I'm gonna delete these two classes and rename this one as the refactor, rename this as the pet. And I probably need a couple more places I need to fix. So I need to fix here. This is just to make my life easy instead of keep adding multiple different entities everywhere, right? So that's some cleanup code there. So I have to read data from my Postgres database. In order to do that, let me add a class that can create a data source, right? I already have a copy of it. So let's say, so what I'm saying here is I have a data source called GW pets for gateway pets. So I'm trying to build a pet store where my pets are in a sample of my pets are in a Postgres database. Some more pets are in a comma separated file. So I will show you how to combine those two data sets together. So here I have GW pets. I'm saying that, and this is the configuration where I need to where my database specific coordinates are defined. So let me go back to the application here, and these are all my, let me put in the definition of my GW pets. Here is the URL, username, password. I'm going to a Postgres database. These two are specific to Teiid, but we'll come back to those later on. It's probably not important at this point. So here I said I'm gonna read from this database. This is the data source definition. Now we need to say that, hey, this is what I want to read from. So we can say this one as the entity class, and define my ID as my primary key. Now we need to say that, hey, I need to read from this database. So I can define a select ID name type status from gwpets.animal, right? Is that animal? Add animals. I want to make sure animal. Okay. So all I'm saying is select these things from there, and going back to my now I'm already reading from that database. That's all I need to do. So, but I need to make my controller ready. So here I'm saying that I need to read. Oh, before I can use that data source, I need to create a repository object in Spring Boot. So let's create a pet repository object. So here I already have a template of it, so let's paste it and utils. So all I'm saying here is I have a pet repository of pets, and find by status is takes a status enum, and that is nothing but select a p from where status is status. Simple. So now going back to the my pet controller, I need to do a pet repository, and let's call it a repo, and I can auto wire this thing in. Right now I need to do the just read the read this read it and send it back. So what I'm saying here is hey repo find by status, and this is the input of the from my open API. I'm reading a status, and I'm getting the data from the database, and I'm gonna return the list back to the so here the same way I can even simply pet by ID. I can do repo find one, and we need to pass in pet ID. That's it. That's all we need to do as far as the implementation of this service, right? So make sure there is no errors. Now I need to execute this. Here is the application. Let me rename this one just to be I'm gonna call this as pet service. Finish up. Now run as Java application. If everything is right, this application should start up. Perfect. Now I can go back to here and localhost 8080, going to, I call it as pet store. There we go. So it's automatically goes to show hide here all the operations, right? I want to find this pet by status. I want all the available pets. Let's say try it out. 406, no content. I think I probably made some mistakes somewhere. Let's see, GW pets, GW pets. GW pets. So the GW pets, it's going me a 406. I think this is because I need to change that to a application JSON, because that's the only one I'm supporting right now. So there we go. So as soon as I changed it, I have the 3 pets that are available. I can change it to pending. You have 1. So remember that I have 1 in each, 3 in each, right? So let's go back to the application again. Now I have the next step is I have a in my pet store I have a CSV file where I have bunch of other pets which I want to combine these things with my pet. So I'm going to go back to my application, kill this one, and I'm just going to copy this one to paste. I'm going to call this one, let's say CSV pet, right? So all right, CSV pet it is. So here I just want to say that, hey, I need to read this data from a text table or a CSV file. So for that we provide another annotation called text table in the in Spring Boot. So I can define, hey, here is the file I need to read the data from, and here is the data structure for it. And that's about it. I don't need to do anything else. I can go back to pet. Now I need to join these, my CSV pet and my previous pet GW animals together. So I can say union all, and I can do the same thing. Copy union all from I called it CSV pet. That's all I need to do. Then let's make sure no errors and start this one again. Make sure my no errors during the startup. Doesn't seem to be. Okay, now let's go back to my my previous. There are 3 rows in there. I'm gonna try it again, and now I have more. I have a Carly trigger, and so I have 5. So if you remember, my had the Carly and Sloopy and Pluto were here, right? So do the same thing with pending. You can see Snowy and Doggy, you know, more available. Instead of there was only 1, now 2. So now we successfully integrated from those from a CSV file. Let's say you have another microservice somewhere, and that is returning some data, and you need to integrate that data with this data. If you remember in the beginning, I talked to you about I broke the service into two different parts, pets and the inventory. That's the, for the inventory part, I just already implemented a service. So I have already an inventory service, and there is nothing specific about this one. All it does is builds an inventory object of pet ID to the price and response. There is no DB involved, nothing, right? So I'm gonna start this service and run as Java application, and this one is running at 8090 port 8090. So let me open up another one, localhost 8090 and store. So it's showing another one. Let's say try it out. So all it has is the pet ID versus the price of the pet. Now I want to combine this data with my other pet. So I'm going to come back to my application. I don't need this. So I'm going to come back to it, and I need to create another object to read this store information. So let's create another class called store, and see if we can read the data from that. So conveniently I already wrote one, so let me paste that and explain it my way through that. So here I'm saying that I have a object called store, and it's got 2 columns, pet ID as well as price. Its JSON name is pet ID, and my database column name is pet underscore ID. And what here I'm saying is I have a JSON based table, and it's reading from an endpoint, localhost 8090 store inventory, right? So that's exactly what this one was, store if you look at it. So that's all I really need to define to read the data from this service. So now I have the pet ID to a price table, but that's not good to consume as is. So let's put it into this table here. So here let me do a little bit of more SQL from so what I'm doing is I have a union of this data. I'm going to call it as A, and I'm going to call it a dot id, a dot name, a dot type. I want to join the other table in here. That's my motivation. So, and I'm going to call it b dot price. So what is b? And I'm saying a left outer join store as b on a dot id equals to b dot pet underscore id. The reason I even showed a different name is, you can, the names what you define and the names on the database can differ. That's one of the value adds of DB, is we can give you that schema evaluation without really changing. You can name it whatever you want in your model, and database can be anything else, right? It's similar to, it's not much different from what Hibernate or JPA provides. So at least at this layer level. I have done a join of everything, but I did not add the price at all here yet. So let's go add the price column. Oops, let's add after the status. Right, that's all I need to do. So I have joined the thing and I have added the column. Now if I can, this is the inventory service, so I don't need to do anything that. So I'm gonna start a pet service again. Let's make sure there are no errors starting up. Oop, that did error. So it's already, there is already another pet service there. So we need to kill that guy and start a pet service again. It's coming up. Looks like we got so again, since I have it in debug mode, you can see there is a virtual database I am building underneath all these covers of annotation based development. But it's, you can essentially do whatever I'm doing on the Java code, but by the means of Java code. You can write strict SQL, either hand code it or use one of our tools. That is our other proposition. If you are using DB in another container, this is the BDB you would put together and then use a JPA layer on top of it. Here I'm trying to show it as a library, as a single unit, especially for Java developers, for who don't want to get out of their IDE, want to do everything what they can just from their IDE, not use any other tools. This also co-locates your, data virtualization or data, DB with your application. So that's another advantage of not thinking these two as two different technologies, and you can use one. So let's go back and see issue another one more time. Not this one. Let's go back to the previous one. Try out again. This time, voila, you have the price added to it. So I showed you, that's probably the end of the demo. I kind of showed you what what we can do, how rapidly we can provide ways to integrate data, right? This is similar for even if you want to insert, you just use your JPA model to insert data into multiple data sources if they are capable of taking a write, right? If you are want to save an entity, it would be no different there. There are a lot more enhancements I was been thinking about. Like, if you want to cache this pet, let's say your data store went down, monolithic data store went down, or you don't want to put so much of a load on you can load on your monolithic data store, let's say, right? You can say something like materialize, right? That should able to save into a local cache, or maybe you want to store it to an InfiniSpan. Maybe we can say source InfiniSpan. That should be possible for me to push the materialized or cache data into a configured InfiniSpan cluster. So that should be doable. The another thing is, when it is in InfiniSpan, we can even think about if there is a change data capture kind of a technology like Debezium is available, right? I can read those change CDC events and put hooks into the Kafka topics for this particular any tables, any data that this pet table is dependent upon. And when that change data comes in, I should be able to update the underlying cache so that we are always serving from the cache, and I'm keeping the up to the minute, I'm keeping it refreshed all the time. So that should be possible, and those are all the kinds of enhancements that are possible. Another thing is CQRS. If you think about, I showed you 3 different sources where I was reading from. You can have a read and a write model, and both read and write model could be 2 different ones. And read model could be much more enhanced for denormalized data, like pet to read or pet to write, right? You can any model, any number of models, and have them specialized for that model, and I'll provide this one as a template in the CQRS based model. There's opportunities we can explore. I think I can probably do that better with little more guidance on from people who have done this kind of a CQRS kind of a thing, and give me a little bit more guidance on what is needed, what is not, rather than me going blindly. So that's one of the reasons I wanted to get feedback. So let me know what do you think of this, and I'm available for anytime if you guys want to talk and give me suggestions or feedback on this demo, or anything to do with the DB and microservices, how we can further evolve this thing, right? Okay, hope you like this so far. Thank you so much for watching. I will talk to you soon.